This is old electronics fan. Well, I decided I was going to play around a little bit, and I thought it might be fun to take you along for a ride. The thing that I want to deal with is there a relatively easy way to figure out what resistor to use when you're replacing a selenium rectifier with a silicon diode. Now, in my previous video on this is the same little tuner, the pilot tuner that I was working on previously. I made a mistake, and I guess I can blame it on the fact that I've done a lot of series string radios, and not so many transformer powered radios. And the difference is quite simple, and most of you probably already know this. I'll mention this for those who might not know. On a transformer set, you've got the output from the transformer. Now this is a newer set, so it's got a diode in the circuit. If it had a rectifier tube, it would have another winding, a 5-volt winding, and the tube would sit across the secondary that supplies the B+, and it would usually be center tapped as well. All of that to say this: if you're measuring the current here, where it's going into the set, your current's going to be higher than it would be if you measure it here, which is the B+. And this is where that resistor comes into play, right here. There's your pi circuit, your diode, your rectifier, and this is the resistor we want to change. You notice this says 2 watts. Well, be careful of that too when you start changing things, because, well, I'll show you in a minute. So, but I started playing around. So, well, yeah, I can just I have a good collection of high watt resistors, and I can sort of mix and match and come up with the current, or the resistance rather, that I want, pretty close to what I want. But what if you wanted to just figure it out? Well, there's a couple of problems with that. Let me see. Do I have do I? All right. Okay, we're gonna get rid of this for a minute. So here's where the problem comes in, and now, if the circuit looked like this, it'd be pretty easy. You add up your resistances, you get the voltage that you're feeding across these, and you also then then that allows you to figure out what the current is, and then resistor by resistor you can find out what the voltage drop is across each of these, and these are ohms, not voltages. That's easy. That's simple. In this radio or this tuner or whatever, this is what you've got. This is the resistor that we want to figure out, but it's in series with parallel resistances. So I'll go back here. So there's our B+ coming out of here. It feeds up to that plate, to that plate, that plate, that plate, and there's resistances in each of those legs, which means this is what you have. But it's not that simple. If I were to calculate the resistances for each of these legs, I would still miss. And this is a simple device. So this is just the plates. We'll ignore that because we're going to ignore that because that's just a diode. You've also got a screen grid here, you've got a screen grid here, you've got a screen grid here. Let's see, yes. So you've got 4 tubes, you've got 8 resistances, but you probably have other things that are drawing current. You've got capacitors here. No, actually that may not, okay, that may not affect it as much. But you've got a resistor here coming off from this coil. There's one there. There's resistances all over the place, and if you have a larger set that has more tubes, the chances of you coming up with an accurate number for this resistance here is very slim. I put in 4, but there should be at a minimum 8. So what can we do? Can we do? Well, that's kind of the question I'm trying to answer. And so this is the resistor that was in this originally. This is a 2 watt. That's what the. Oh, I know. Stop it. Don't yell at me. And one of the downsides of this old Radio Shack is I don't have the ability to turn off the. I haven't looked, but I don't think there's a way to turn off the timer. This one you can, but anyway. So here's what I've done. I was starting to change this out from the 3 lug to this 5 lug terminal strip, and I was going to put this resistor in there. But you know, I thought, well, this is a 2 watt. Why don't I try to get one of those? But then it occurs to me, because you're going to be dropping more voltage across the resistor that replaces this one, the wattage is going to be higher. And we're going to figure that out shortly. So, alright, let's go to, alright, I wrote myself some numbers and notes, but I'm going to show you in real time what we're dealing with. So right now I've got this meter set up that will allow me to read both sides of this resistor, and then I'll just use my leads to measure across this. This is going to tell me what my current is, and I'm measuring right here on this one winding, going out of, actually it's coming out of, so I'm on this side and I'm measuring between here and here. So this is all DC voltage, and this is the current that's actually supplying the B plus ultimately. Well, it is what supplies the B plus. So this is the DC voltage because we're after the diode. So if I went before here, the current would be, well, number one, I'd be dealing with AC voltage, and now whatever voltage drop would be here in the diode would affect the current a little bit, small amount. But this is where I want to measure. This is what matters right here. So that's why I'm measuring where I am, because this is the thing that I need to figure out. So let's turn this on. I think we're good to go. Yes. Give it a minute or 3 to warm up. And since I know what that's supposed to be, it's got to be lower than that. Yeah, it's coming down slowly. Come on, keep going. Give it a minute or 2 more. Now, alright, 122. If I leave it on a bit longer, I know it's going to drop because I've played with this. I wrote 121 down in my notes. and maybe eventually it'll come down, I don't know, but a volt's close enough. I said 121, that's 122. Now I want to look at the voltage on my plate up here. It's 120 volts. I'd like it to be closer to 98 volts. Oh, that's another thing I want to mention, is the voltages don't have to be exact, and most of the time you're not going to be able to get them exact. Power transformers sometimes put out a little bit more or a little less voltage than what they're supposed to. You're dealing with aging components, and even though I've replaced all of the resistors that were out of spec, I haven't done anything with the tubes. I haven't even tested them. And part of the reason for that is because the tuner seems to be working pretty well. If I want to find out what the health of these tubes is, I could. The health of the tubes will affect the plate voltage that you get, that you measure. I have two tubes, 118, so that's come down. Okay, let's see what this does. Okay, 120, interesting. All right, I wrote 121, now it's dropped to 120. Okay. I had this on a few minutes ago, so apparently it's warmed up pretty quickly, so the voltage has dropped a little bit. I'll just change that. Doesn't really matter, volt one way or the other. All right, now I want to check the voltage across the resistor. 32 volts, and I wrote 30 volts. So, yeah, okay, fine. So, 32 volts, 30 volts. All right, I'm not sure why that went up. I'll make note of that instead of what I wrote. 32, we'll say. It's almost 33. Yeah, almost 33. 32 is close enough. Doesn't have to be absolutely precise. Okay, now, so we know that the plate voltage, what did I say it was? 117. It's dropped a little bit more. I'm not entirely surprised. Well, I'll write it down because that's what it's actually doing. Okay. No, actually it's here, 117. And what did I say that was? I erased the wrong thing. No. 118, let's say 119. 119, all right. And 152 still seems to be correct, so, all right. Now, let's play, shall we? Over here, I'm going to start this recording up. My phone keeps timing out on me, you bugger. All right, let's see if we can get, okay. All right, so you should be able to see this. I've got this Ohm's law calculator, and I'm going to go back to this. 60 milliamps is that what? Oh, I didn't look at that. Oops. All right, come on. The voltage has changed a little bit. 60, 61. Okay. 62. It's changing. It's not going to matter too much there. And when I get to the other resistor, we'll try to get the precise. All right, so this resistor is 510 ohms. And 510. Now it says the voltage drop across that should be 30 volts. Let's see what happens if I jump this up. Yeah, okay, so that does make a difference, because my voltage was 32. Okay, so now let's go to this resistor right here. This is a 1K ohm resistor. And yes, alright, fine. It is definitely warm. Okay, so now we're going to do the same thing. I'll let it warm up. Okay, light is on, that's good. I can check this. This is the outside. Okay. I traded sides when I swapped that out, but that's okay. So, I want you to notice something. That's 51 milliamps, not 62. So the current has changed. Not too surprising, because we have a higher ohm resistor in the circuit. So that also impacts, this matters when you're trying to figure out what the wattage is, and we'll look at that in a minute also. So now I've got this 51, is that what I wrote down before? 52 is what I had before. So it must be because this has warmed up more, it's changed things on me, but that's okay. Alright, so now let's look at this side. So this side is what's coming off the diode, 55, and 156, that says, so my voltage has changed together a little bit. 103, I had 104 after the diode before, it's okay. We'll be fine. And then we go up here to our plate. Okay, that's interesting, because I had 99. Okay. Alright, so I want to check the voltage. Interesting. I'm going to check the voltage across that, and this is 52, and that's what I had before. Alright, so now I've got, so now I want to go 52 milliamps, and I'm going to go down here to my ohms, and 1K, I think I measured this pretty close to that. So my voltage drop, it says is 52, what does this say? 52.8, we're close enough. We're not going to, we're not building a rocket ship here. Alright, so the difference between this resistor and this one, as far as the voltage drop, this one is 32 and this one is 52, so that's a 20 volt drop. I'm kind of surprised, dismayed actually, that has gone up that much. 100. Now I would be happy with that. Alright, so let's look at something here. Can I use this method to figure out what I want? Well, I know at this point where I'm getting 100 volts, I want 98. I would be fine with 100 volts. 2 volts difference at the plate, that's fine. It might possibly be fine at 117. Maybe I'm just being a little bit anal and perfectionistic. Plus I worry a little bit about tube life, I guess. The one that I really care about a lot is the filament voltage. And unfortunately, this one's running at a higher filament voltage, like 6.5 instead of 6.3, which is what the tubes are rated. It's probably okay, but and if I were to try to fix that, I would have to insert a resistor in the line for the filament winding. to try to deal with that. And that would be another fun thing to figure out. So anyway, before I wander too far afield. So, let's check this again, see if it's getting any better. 100 volts. All right. So, I know this number because I experimented with putting this in. The difference in the voltage drop that I was looking for was I wanted a 20 volt drop. Now here's where it gets interesting. And here's where it gets challenging. Let's go back here. And would I say that was current, well, 60, I think it was actually 62. We'll use that. This tells you that the voltage I would be dropping across that resistor is 62 volts. And so if I was trying to figure this out, try to figure out what the right resistor is to use, I would guess that I would need to go, let's see, oh, I wanted both those. I would guess that I need to go down to 800 ohms. And I would if this was true. But, well, my camera drifted on me. Stop. Don't do that. All right. So, you kind of have to play with stuff. You kind of have to guess, okay. So this then means that I would want to go, if I say 900 or I say 950, that would be fine. That would get me close, but you'd have to know that. So, and the problem is, I don't know that you have a way to figure that out on the fly. Because, yeah, I'm not sure how you would do that. Because as I mentioned earlier, you can't figure it out from the resistances that are involved in this circuit. I don't think you can. So, you would still have to be doing some guessing. And I don't know. Yeah, I don't know how you would do that because there's too many unknowns. All right, so let me go to the next point though. And this is the existing resistor that was in the tuner. Had a 30 volt drop, 32 volt drop, 60 milliamps, 1.8 watts, and this is rated at 2 watts, I believe. I finally saw a 2W on there, and it looks like it's part of a part number, but I believe the 2W simply stands for 2 watts. And maybe the part number is 2W something, identifying it. So what happens when I go to, say 50 volts? Now my watts has changed, and if I go to, let's say it was 52, let's see what that does. 3.12 watts. What that tells me is I don't want a 3 watt resistor. I probably want a 5 watt. So, this does help me figure out what size resistor I want. And actually, the milliamps is wrong. Let's see, let's go back to this, because I have 52. Let's see, I didn't change that. Okay. So, now that I have the correct voltage drop and the correct current, it says 2.7 watts. But I think I would still probably go with a 5 watt resistor. And I was hoping to get something small like this to put in there, and I just tack it across that, and I could just put that 3 lug terminal strip back in there. my other radio, I did use one of these on it, and ooh, that's very hot. Even 10 watt gets very warm. We don't need you right now. So, and this probably worked just fine with the way it was before, kind of. Of course, I didn't. Yeah, okay, so yes. I measured the current. I know the voltage drop across it, and that did tell me that 2 watts was fine. So, I'm trying to keep my batteries from dying. So, so this is I guess has value in terms of finding out what size resistor you want to go with. And I could probably get away with a 3 watt. But having a higher wattage resistor in there is certainly not going to hurt anything. It might help it run a little bit cooler, and it probably lasts longer. So the question is, can we use this method to try to make things easier? I think the problem is going to be we're going to have to know the current. And I don't know unless somebody can come up with, yeah, so there's 52 volts. So the numbers are all working out just the way they're supposed to. So I guess you've got too many moving parts in terms of, well, I say too many. You've got some moving parts that you can't say for sure give you what you want. Because our goal was for this number to be 20 volts higher than the number used for this. The problem's going to be that we aren't going to be able to figure that out because we don't know what this is. Now, we can play with this and come up with a ballpark, and we could, I guess, at a guess say, okay, I've raised this by double, it's going to drop my milliamps by 10, we'll just say, just for laughs and giggles. And you know, if you do something like that, it would probably get you pretty close to the number that would tell you whether or not putting that in will resolve the issue of a voltage that's about 20 volts higher than you want it to be. So, because I was thinking I wanted a 950 here, and but as you can see, it doesn't drop as much voltage. So what would happen if I went 100, 57 volts? So that would probably be too much. So if I said 050, that's again pushing it. So I mean, the thing is, once you come up with a working number, you can figure out what you might want. And I don't know if you can get resistors in these sizes. Good grief. Okay, so I'm 2 volts, so I want to go 2 volt. All right, yeah, 54 is what I didn't want. So what is that? So that would be really close. So if you were able to get a 1030 ohm resistor, then that would get you pretty close to what you want to be. So it's almost 2 volts higher. Like I said, I'm probably going to be fine with putting a 1K ohm resistor in here. If that's going to be around 100 volts on my plate, I think it'd be fine. It's not that much higher. So going back to the higher plate voltage, just running through my mind how that works. With the plate being more positive, because that's what the higher voltage does, it's possible that that plate would be drawing more current, because up to saturation point, it's going to want to pull it's going to be more, the electrons are going to be more strongly attracted to the plate, so they're likely to flow more. So the bias of the tube, the bias on the tube is based on a certain plate voltage. And you'll notice if you look at some of the tube manuals, well, I'm not going to spend a lot of time on that. But in the RCA R35, I believe the output tube was a 47, and I believe they had 3 different plate voltages listed, and the voltage, the bias voltage ranged, I think, between 35 volts and 54 volts, depending on which plate voltage you used. And so it's stuff like that that leads me to believe that, yes, the plate voltage does matter, that the bias is set and that is engineered to work with a certain plate voltage. So for best performance, you probably want to get your plate voltage somewhere near what they spec'd out for that particular device. In my case, they say that it should be 98. I said I think a couple volts one way or the other isn't going to matter too much. And you can see that depending on how long you play it, the voltage changes. Just to make it more fun. But, and it looks like the voltage dropped the longer this was playing. It's only going to go just so far. And I did, at one point when I was playing with this, I think the voltage actually got down to 99 volts. And that was definitely would make me happy, and that was with this resistor. So can you use this technique so you don't have a whole collection of resistors like I did? Can you use something like this? And what's really nice about this electronics assistant is you can play with the numbers, not that one. You can play with the numbers, go back here. You can play with the numbers here, and that gives you an idea of what to expect.
So they show you the formula.
And you don't have to do any hard calculating. I mean, this is kind of a learning tool, so they show you the formula for each of these, everything that you're doing. The formula changes depending on what you've got.
And definitely helpful.
So you can plug in the numbers and come up with an idea of what to expect. And definitely helpful if you're trying to say, okay, what should the watts be?
I may find myself using this in the future, just as a way to get me close.
I may find myself using this in the future, just as a way to get me close. Because now that I know that the milliamps is going to drop, once you increase the size of the resistor, the milliamps is going to drop, and I might just start with, if I'm doubling the resistance, if the new resistor is going to be twice the value of the resistor that was in there, or thereabouts, I'm just going to automatically say, okay, so the milliamps is going to drop by 10. And I'll start there. And then I can either just quickly grab a combination of resistors to see how that looks, or I might even order a resistor based on that expectation. So anyway, I just thought this might be fun to play with. Definitely was interesting. As I was thinking about this, I really didn't think about the fact that you were going to be dealing with this. Well, I had to dig into this because I just really wanted to get an answer for myself. And the question that needs an answer is there any way to treat, let me back up. This wire you see sticking out here is this wire right here. I've disconnected it. And so the question is, and I know the answer after some thought, and anyway, can you measure between here and here and come up with a resistance number for this part of your device? The answer is no. And there's one thing I actually overlooked in the process of trying to figure this out, and it's pretty obvious, but you know, I wasn't thinking through this as much as I should have. All right. The resistances you see here, where you have actual resistors, there's one for the screen grid, there's one for the plate, which means there's 8 resistors. You also have a bunch of capacitors. This goes to ground from the B+. That one does. There's a whole bunch of them that do. So, just to confirm to myself that just on the basis of the capacitors you have in there, it's not possible. So I hooked up my meter, and I hooked up between the B- chassis and this point with this wire disconnected from the capacitors, because I knew that would be an issue, obviously. And the end result was what I expected. All those capacitors were charging up, the resistance was changing value as they charged. Bottom line, you couldn't trust the number that you got from that, I don't believe. But the problem gets worse. If you're measuring this with this not running, you're leaving out some important resistances. Each of these tubes is essentially a resistor. You have current flowing through the tube. This tube has a grid that affects that flow. Each tube has an effective resistance. And that resistance is going to vary depending on the signal being sent to the grid of each tube. And that, therefore, well, if you could wind up with 0 signal across the board, you could come up with a resistance for each of these tubes. You could do some measurements and you could come up with a reasonable resistance measurement for each tube. I've never tried it. It's not important. I don't care if I know that or not, because I'll never use it. I don't need it. But the bottom line is, the only way you're going to be able to measure this as a unit and determine its equivalent resistance is by measuring this while it's operating. I've thought about this for quite a bit, and I don't believe there's any way you can do this. Plus, coming from the diode, feeds through this resistor, the one that we want to get a value for. This is the equivalent resistance of this part of the circuit. Here's one of the problems that I've been going round and round about. When I'm measuring, I'll just leave that there, put that there. When I'm measuring the voltage here, I'm measuring between here and here. This is the chassis ground. If I'm measuring the voltage here, I'm measuring between here and here. Again, chassis ground. When I measure here, it's 155 thereabouts. When I measure here, it's 103 roughly. That tells me the voltage drop across this is 52. That's with my larger 1K resistor in place. Yeah. So, 103 volts here, 155 volts here, that tells me what the voltage drop across this resistor is. That's easy. Where do you go here to try to find out what the voltage drop is across this part? Can you find that out? I've concluded that you can't really. So that's a major problem. You can't really do that. And I can draw this, but where's the point over here where I can say, yeah, I can measure between here and here and get a voltage drop reading? Well, I can't because I measure between here and here, and that only tells me what this is, what the voltage drop is across this. So I was hoping, I kind of knew this wasn't going to be possible. I was kind of hoping that, this would be this resistor and then this would be this. So if I could come up with a resistance for this part, I know what this resistance is, you add them together, use Ohm's law and the voltage that you measure here, find out what the current is, then you can find out what the current drop is here, or the current is here, etc., etc. Now, one of the things I did do was I disconnected this wire right here and hooked my meter in series in ammeter mode, which you saw me do in the video, and so I got the current flowing, but then of course I was able to measure across this resistor to get the voltage drop. But by knowing what this current is, that also enabled me to find out what wattage this resistor should be. And even though this has 2 watts for this resistor, as we just found out, that's not accurate for the new resistor. So, my conclusion is simple. The best that you can do is find out what the current is that's flowing from here to the new resistor, so you find out what watt resistor you really want to use there. That's all you can do. I don't think you can calculate. Now, I mentioned that maybe I could guess that because in doubling this resistor from 510 that was what was in the radio, the tuner. Going from 510 to 1K drops the current by 10 milliamps. So I could sort of guess that if I'm doubling the resistance, then I would expect an appropriate drop in the current. But that's for this, and the current that this uses. Or if you're using something that draws more current. This doesn't have an output tube. It's got a diode. And that's the output for this unit. It sends that audio out here to the amplifier, which then has your output in it. So this is not really a good representation. I think I've already said that in the video, so I won't rehash that. So my conclusion is simple. Trial and error is probably the only way you're going to get this resistor value here. You can break this line, the wire here, you can get the current flowing through that resistor and determine what wattage resistor you really want to use there. I mean, I have a bunch of 10 watt resistors that I use when I'm playing around with this. That's typically more than I need for the device, for the items that I work on, the electronics that I work on. So that works out great. Now, like I said, I could just go ahead and just stick another 10 watt in there and call it done. But sometimes you might not want to go that big, and maybe you want to try to get a smaller resistor to fit into a spot where, because you don't have a lot of room, or you want to fit better on the electrolytic if you're still using the multi-section electrolytic. So the end result is the best you can do is try to determine what the wattage is by using your meter. And once you know what this resistance value is by substitution, and that's the conclusion I come to. I'm not disappointed by that conclusion because that's pretty much what I expected. But I said, well, I really want to confirm that for myself. And I thought, you know what? It might be fun to just put this out as a video and let you go along for the ride with me. And it was kind of a ride, but I spent an awful lot of time trying to sort this out, trying to figure out is there anything I could do that could possibly enable me to do what I want to do? And the answer is, my conclusion is, there's no options. You've got to manually swap in resistors until you get the value that works for you. And I've done that a lot of times on a lot of radios, and it works. Like I said, I happen to have a pretty good collection of resistors that allows me to get close. One of the nice things is that once I get a resistor value close to what I would like it to be, I could then use the electronics calculator software and play around with values to try to get closer to what I want for a resistor. And then I can, with reasonable security, order what I want or what I need. And that's about it. And because as you saw, I put that 1K in there. I found out what the current was. I could then play with the values of resistors that I could use to get me closer to my goal of dropping the voltage by 20 volts. So that's the conclusion I come to, though, is that that's the best you can do. And it involves swapping in resistors and making your best guess, and that's about it. So I like I said, I did enjoy this. It was interesting. I have now confirmed pretty much what I was thinking, that there's no options for doing other than what you're doing. And I'm sure that's not a surprise for many who probably thought it through before I did, and they probably already knew, because they're greater experience than what I have. They already knew that that was doomed to failure, trying to come up with a way to calculate that resistor. So, but it's been fun, it's been interesting, and I hope you found it interesting. I look forward to your comments. And you could tell me that I was crazy for even trying this. I already know that. But I just thought I'd do it for the fun of it. You can tell me that there might be a way to do this. I just don't happen to know what it is. If you do, great, let me know. But apart from some other way of doing this that I'm not aware of, I guess I'll just keep doing it the way I'm doing, because it works and it gets me where I want to go. And it's really not all that hard. Like I said, I've got, I don't know, probably 8 or 10 high watt resistors I can use to substitute in and out to try to get the value close to what I want. And I think I may have already mentioned this. This little unit is not a typical unit. I'm only guessing, but I think the current flowing through the B+ circuit in this is lower than in a typical radio, for example. And I think part of that's going to be because in a radio you have an output tube, at least one, and they draw more current. Some radios run tubes at a higher plate voltage than this does. So it would be hard to say, okay, I've doubled the resistor size. That means I'm going to drop my milliamps by 10 milliamps or whatever value you initially measured. I'm not sure you can say that. I'm not sure that's going to be an accurate conclusion to make. So, anyway, I think I'll stop yammering, and I will close this video here. Look forward to your comments. I hope you will chime in. If you liked it, let me know, please. Love to have you subscribe, and hopefully you'll join me on the next video. Thanks.